So we are going to be doing we're going to talk about the review of simplifying radicals. So there's a few important rules for when we simplify radicals. And one of the rules is that the radicand cannot have any perfect square factors. For it to be fully simplified, it cannot have any perfect square factors. The radicand, remember, is the thing under the radical. The radicand is not a fraction. Okay, we can't have any fractions for our radicand. And, big one here, the denominator cannot contain a square root, right? So those are our big rules for simplifying radicals. So we are going to focus mainly on this top one here as I review with you guys today. And then we are going to kind of, and then we'll see what we have as we go here, all right? So the denominator, and then we're going to talk a little bit more about how it can't be a fraction and how the denominator cannot contain a square root when we multiply and divide. So I'm only going to do a couple of examples for you guys, okay? So let's look at example 1. We are going to take the square root of 200. So remember, does this have, is this a perfect square? Square root of 200, is that a perfect square? Let's check it out. No, it's not. It's a very ugly, irrational number, so that is not a perfect square. But does it have any perfect square factors? Does it have any perfect square factors, y'all? Can we divide 200 by any of our perfect squares? Yeah, 100, right? It's actually also divisible by 25 and 4, but we want the largest perfect square, right, factor. So we could rewrite this as the square root of 100 times the square root of 2. Are y'all comfy with that? Is this kind of bringing back any bells here? Maybe. Not so much. You guys are sad. No, I'm kidding. All right, so here we go. So then the square root of 100 times the square root of 2. Well, guys, what's the square root of 100? 10. So this just becomes 10 times the square root of 2. And we have our final answer. Do you guys feel good about that? Because the square root of 100 is 10. That's the whole point. We want to find these perfect squares. Now, guys, if we looked at this, remember, we said the square root of 200 was this big, nasty-looking decimal. If we do, if we do 10 times the square root of 2, we get the exact same nasty-looking decimal because they are equivalent to one another. Do y'all feel good about that? So you can always check yourself on your little trusty calculator over here. All right? For example 2, we're going to do, let's see, the square root of 108. What is the largest perfect square factor that is a factor of 108? Well, what are some good factors of 108 there, y'all? 4, 9, 16, 25, any of those guys. So we can just check ourselves here. Now, you can say 108 is actually divisible by 4, but I don't think that's going to be our largest perfect square. So let's start with bigger ones. You guys got any numbers for me that could be factors of 108? 36. Let's try 36. 3. Do you see that? That's so much nicer. So 36 is, there we go, much larger than 4. Sorry. So we want to go with the square root of 36 here. So always put that perfect square factor first because it just simplifies a little bit prettier when we do that. So then we say 108 is divisible by 36 and 3. And what is the square root of 36, y'all? 6. So that's going to be 6 times the square root of 3. And let's see if we're done here. Let's double check ourselves here. The square root of 108 is that nasty looking decimal, irrational number. And 6 square root of 3, oops, go to, oh, I didn't put anything in there. Okay, square root of 108 They are the exact same nasty looking decimals. Do y'all feel good about that? Yes? Maybe so? Not so much? Alright, so we feel good about those guys right there. Those are the exact same nasty looking decimals. Is that a good little refresher there on simplifying radicals? You just want to find the perfect square. Okay? So now I'm going to do a little like line here kind of in the middle. So guys, the big thing that we're going to be talking about today is we're going to be talking about adding and subtracting radicals. Okay? So we are going to be talking about adding and subtracting radicals. Now we need to remember how to simplify when we add and subtract radicals. And so here's the thing about adding and subtracting radicals. We want to look for like radicals, okay? So this is going to be our big thing here. You can combine like radicals with addition and subtraction. Okay? So, whoops, not subtractions, but just subtraction. Yay, English. Alright. There we go, with addition and subtraction. But guys, like radicals, what is a like radical? Well, let me define it for you guys. Okay? A like radical is very similar to a like term. Okay? Like radicals are square root expressions with just adding letters with the exact same radicand. Basically, the thing under the radical is exactly the same. Okay? So like radicals are square root expressions with the exact same radicand. Alright? And our rules, we do have a couple rules here. Alright? Is that we, let's see here, I'm going to write our little rules here. So our rules is that you can add or subtract the coefficients, but do not change the radicand. You don't change what's under the radical. So you can add or subtract those coefficients, but you can't actually change the radical. Alright? Sorry, y'all. And then, kind of a sub-rule, so I guess this is rule number 1. And rule number 2 here is that you always make sure you simplify the radicals or the radicands before adding or subtracting. Alright, so we always want to make sure we simplify. Man, that radicand looks really funny, but that's okay. That N was just huge. You want to make sure you simplify the radicand before you add or subtract. Do y'all feel good about that? So these are some of our rules. You can combine like radicals with addition and subtraction, but when you combine them, you just add or subtract the coefficients, but you don't change the radicand. And you always make sure you simplify it before you add or subtract. Alright guys, so I'm going to give you guys a few little examples here, okay? So for example 1, I'm going to do 3 times the square root of 7 plus 8 times the square root of 7. Alright, so let's take a look at this, guys. First of all, let's look at my radicands, my square roots of 7. Can that be simplified at all? No, neither can that one. Now we take a look and we say, look at this. We both have square roots of 7 right here, don't we? So we can put those guys together. So 3 plus 8, what's 3 plus 8, y'all? That's just going to be 11 times the square root of 7. Do y'all feel good about that? And that is our answer. 11 times the square root of 7. That is our simplified radical right there. And guys, you can even check yourself on your handy dandy calculator. You can say 3 times the square root of 7 plus 8 times the square root of 7. And it's going to give you a really nasty looking irrational number. And guys, that's the exact same thing as 11 times the square root of 7. So you can always check the answer you're given with the answer that you get, or with the problem you're given with the answer that you get. Alright guys, to make sure they match. So that right there is a good example. Alright, now we're going to look over here. I'm going to do another example. Example 2. So this one's going to be 4 times the square root of 10 minus 2 times the square root of 5 minus the square root of 10. Alright, so are all of these radicands simplified? Let's take a look here. The square root of 10, is that simplified? Yeah, we're good. That's not divisible by 4 or 9. Yeah, so that's simplified. There's no perfect square that can be divisible. 5 is simplified, and 10 is simplified. So now we're going to find our radicands that are like. So we're going to say, okay, square root of 10 and square root of 10. Look at that. Now we're going to add our coefficients together. Add or subtract our coefficients. So we have 4. What's the coefficient of this one, guys? It's like a negative 1. So we got this guy here. So 4 minus 1, that's going to give us 3 radical 10. And then do we do anything to this guy over here? Minus 2 radical 5? No, we're done. That's it. Do you guys feel good about that? So if they are like terms, you can put them together. If they are not, then you don't put them together. It is that simple. Alright guys, do y'all feel good about that so far? Alright, so now we're going to go ahead and we are going to do a few more examples. Alright, or I guess not examples, we're going to actually try to simplify these. Alright, does everyone feel good about these pages right here? Awesome. Alright, so now on your second page here, we are going to simplify. Alright? So I want you guys to simplify these. Alright? So for number 1, I'm going to write this as 7 times the square root of 5 minus the square root of 50. Y'all feel good? Alright, so what we are going to do is we are going to see if we can simplify these. Well, first of all, are our radicals simplified? That's what we want to check out first, right? So 7 square root of 5 minus minus the square root of 50. Well, guys, is the square root of 5 simplified? Is the square root of 5 simplified? Yeah. What about the square root of 50? Is that simplified? No, we're going to have to simplify that. So what do we need to do here, y'all? Yeah, 25. So that's going to be the square root of 25 times the square root of 2. So that's going to reduce this guy into 5 times the square root of 2. Do y'all feel good about that? This one is just going to travel down as 7 times the square root of 5. And we have 7 square root of 5 minus, 5 square root of 2, right? So now, can we put these guys together? Are they like radicals? Square root of 5 and square root of 2, are those the same thing? No. So this right here is as simple as this one gets. Do you guys feel good about that? It's a little bit weird, but that's as simple as it gets. Alright. Because we simplified the radicals, but we can't actually put those guys together. This is like apples, that's like oranges. You can't put your apples and your oranges together. Alright, let's try radical 12 plus radical 27. So first we need to simplify our radicals, don't we? Alright, so let's take a look here. How can we simplify 12? Yeah, 4 and 3. So we're going to do square root of 4 times the square root of 3. And that's going to reduce down to 2 times the square root of 3. You guys comfortable with that? And then 27, that can be simplified into, what is the largest perfect square factor? 9. So that's going to be plus the square root of 9 times the square root of 3. Well, guys, the square root of 9 is just 3. So now we have two different radicals here. Now, guys, do we have the exact same radicand? Square root of 3 and square root of 3? So we can put these guys together. So 2 plus 3 is 5. And then radical 3. And we are done. Do you guys feel good about that? We're putting our like radicals together. Okay? So now we're going to jump down here. We're going to look at number 3. So for number 3, I'm going to stretch it a little bit. We're going to do 5 radical 12 minus 7 radical 8 plus 4 radical 3. All right, we got 3 now. Yikes. All right, so let's check it out. So we are going to, now we need to simplify this guy. So this is going to be 5, and we already did radical 12 up here, didn't we? So that can be radical 4, radical 3. So that's going to be 5 times 2 times radical 3. So this is going to be 10 radical 3. You guys good with that so far? Okay. Can we simplify this guy at all? Can we simplify radical 8? It's divisible by 4, isn't it? So that's going to be 7 times radical 4 times radical 2. And that is going to be negative 7 times 2 times radical 2, which is going to give us negative 14 radical 2. Are you guys good with that? So I'm simplifying each term to see if we have any like terms. Does this one need to be simplified? No, it already is. Radical 3 doesn't have anything. So that's just going to be 4 radical 3. Are you guys comfortable with that? Now we want to find our like radicands. So we have a radical 3 and a radical 3. So we are going to add our 10 and our 4 together to get 14 radical 3. And then this guy's still just kind of on its own, minus 14 radical 2. And that would be our final answer. You guys feel good about that? Ish, maybe? Alright, let's do another one. Alright, so we have 3 square root of 200 plus 4 square root of 20 minus 6 radical 5. So we want to go ahead and we want to simplify our radicals. So I'm going to rewrite square root of 200. I'm going to say 3 square root of 100 times square root of 2. And that's going to be 3 times, whoops, not the square root. What is that? 3 times what, y'all? Times 10 times the square root of 2. So that's just 30 square root of 2. You guys comfortable with that? Then we're going to go over here, plus 4. What is the largest perfect square that is a factor of 20, y'all? 4. Exactly right. So that becomes radical 4 times radical 5. We just split up that radical 20. And so that's really 4 times 2 times radical 5. So we have 8 times radical 5. Excellent. And does this one need to be simplified at all? Nope. So I'm just going to say minus 6 radical 5. Alright, you guys feel good about that? So this is going to be, now we want to find like radicands. So we have radical 5 and radical 5. We're going to, does this one have anybody like itself? No. So that's just going to be 30 radical 2. But then we do 8 minus 6. So that gives us 2 radical 5. Do y'all feel good about that? How do we feel so far? How's the addition and the subtraction? Not so bad? It's not so bad, y'all. It's really not so bad. We're going to do 2 more examples and then we're going to move on, all right? So let's take a look at number 5. Whoops, I was supposed to do it in black pen, but you guys will forgive me. All right, so number 5, I'm just going to list out as 5 radical 28 minus 8 radical 7. So, do we need to simplify radical 28? How can we simplify it? What's the largest perfect square factor out of 28, y'all? 4. So that's 5 times radical 4 times radical 7 minus, does that really need to be simplified? No. I should probably finish this one first. Sorry, guys. I'll finish this left side before I keep going. My B. Alright, so if we want to simplify this, this would be, what is that? 5 times 2 times radical 7. Y'all feel good about that? So that's what, 10 radical 7? I'm going to go ahead and simplify it fully before I move to the next thing. Does this one need to be simplified, y'all? No, I just don't want to write it 3 times. So I'm going to say 8 radical 7. So now, do we have any like radicals here? Yeah, radicand and radicand. So we can put everything together. So what's 8? What's 10 minus 8, y'all? That's 2, right? So we got 2 radical 7. 2 radicand 7. Radical. The radicand is the 7. The number under the radical is the radicand. Yeah. So there we go. So 2 radical 7. Do y'all feel good about that? Alright, last but certainly not least, this one's a little bit weird. So that's why I want to make sure we do at least one like this. We're going to say 2 times the square root of 45 over 3 plus 4 times the square root of 18 over 6. Alright, this is going to be a little weird, but it's okay. So we're going to do one at a time. Are you guys cool with that? So, can we simplify this radical 45 here? We sure can. So what is that divisible by? Are there any good numbers that's divisible by? 9, yeah. Radical 9 times radical 5, right? And we're just going to put it over 3. Are you guys still, we haven't lost that yet. So that becomes 2 times 3 times radical 5 over 3. Oh man, this is getting kind of long, sorry. So that becomes 6 radical 5 over 3. Okay? Now can we simplify this at all? 6 divided by 3 is 2. So this is just 2 radical 5. So this guy right here, 2 radical 45 over 3, simplified all the way down to 2 radical 5. Alright? Then we're going to go over here, and we're going to say plus 4. Well, can this one be simplified at all? Yeah. Square root of 9, square root of 2. Are you guys comfortable with that? Over 6. This becomes 4 times 3 times radical 2. And it's still over 6. 4 times 3 is what? 12. Radical 2 over 6. Would you look at that? Are these going to simplify? Yeah, so what's 12 divided by 6? That's 2, so it's 2 radical 2. So we did all that work. And guys, can we even combine these? No, they're not even combined radicals. However, this looks way nicer and prettier than those fractions we had earlier, weren't they? So 2 radical 5 plus 2 radical 2 is the exact same thing as this guy up here. How do you guys feel about adding and subtracting radicals? Y'all feel okay? We mostly, you just got to make sure you simplify each radicand first, and then you combine your like radicals, if there are any like radicals. Okay? So if you wanted to write a little note on your notes, you cannot combine unlike radicals. Okay? Because they are already simplified. Do you guys feel good? So that you can't combine your unlike radicals there at the end. Okay? Alright, how do you guys feel about this? It's not a bad Monday. Not a bad Monday. Alright, so now guys, what I want us to do is we are going to work on, we're going to multiply. We're going to talk about multiplying radicals, multiplying and dividing radicals in just a minute. Okay? You guys feel good so far? Awesome. All right, so let's turn the page. Or if you guys just want to, you guys might, if you have about half a sheet left, you could probably fit it on the rest of the sheet too, if you want to do that, okay? So we are going to be talking about multiplying radicals. Multiplying radicals now. Okay? The biggest thing about multiplying radicals is you will have to simplify your radical. You want to multiply your coefficients. All right? So here's your little rules to follow. Okay? Rule number 1. You multiply your coefficients. Okay? Rule number 2. You multiply the radicands. And then the third step there is you simplify it. Okay? Using the rules that we just did here, okay? Or that we used up there earlier. So let's take a look at some of these guys, okay? So let's see, if I had, we want to simplify these, if I had 5 times radical 2 times radical 2, the first thing we want to do is we want to multiply our coefficients. Well guys, 5, what's the coefficient of this radical right here? It's like a 1. So 5 times 1 is just 5. Then we want to multiply our radicands, the radicands under there. So what is 2 times 2? So this is 5 times the square root of 4. Well guys, is this going to simplify for us? Sure is. That's going to be 5 times the square root of 2, or 5 times 2, which is going to simplify into 10, because the square root of 4 is just 2. Now this one happened to be a nice pretty number. Most of the time they don't always work out that way, okay? So let me do another one for us, okay? So let's take a look at number 2 here. Okay? What if I do 2 times radical 2 times 4 radical 6? So the first thing we want to do is we want to multiply our coefficients. So what's 2 times 4, y'all? 2 times 4 is 8. There we go. And then 2 times 6 is 12. So this becomes 8 radical 12. Now, can we simplify this radical? We sure can, can't we? So this is going to become 8. What's the largest perfect square factor right here, guys? 4 times radical 3. There we go. And so this is going to be 8. And then what's the square root of 4, y'all? 2. And we're just left with radical 3. So this is going to be 16 times radical 3. Are y'all comfortable with that? So we are just multiplying 2 things together here. Alright, we're going to do another one of these guys, okay? So we're going to do number, let's see here, let's do number 3 here. Okay? So we are going to say 2 times radical 6 times 3 radical 8. And then I'm going to write both of these up here if you guys would like to work ahead a little bit. Times 2 radical 6. Alright guys? Now let's see what you do. You want to multiply your coefficients, and then you want to multiply your radicands. And once you've done that, then we simplify. You kind of check your work. I want you guys to try to do these guys on your own. See how you do. And then you can kind of check yourself up here. any questions? So far on how we multiply these radicals together. Alright, do you guys have any questions on numbers 3 or 4? Does this look pretty good, guys? Y'all feel good about this so far? Okay. Now, one thing that I do want to talk about, guys, is if you are given a radical with no coefficient, like let's say, or if you are given just a coefficient, like let's say I do 3 times 2 radical 56 or something like that. Well, guys, then you still do your coefficients together, and you do this guy on its own, and then you simplify the radical. There's just no radical to multiply over here. Okay, guys? So even if there is no radical to multiply, you can still simplify this. Let's hear. What is it, 4? What is a factor of 56? The largest square root of 5. Let's see here. 56 divided by, 4. So we're going to say square root of 4 times the square root of 14. So that's 6 times 2 times the square root of 14. So that is 12 times the square root of 14. Alright, guys? And don't forget, you can always check yourself by putting the original problem in the calculator and putting your simplified answer in the calculator and making sure you get the exact same answer. Alright? So that's what I'm going to put right here. Remember, check the original problem and the answer in the calculator to make sure they are the same. Okay, so you can always remember, you can put them in the calculator to make sure they're the same so that you know that you simplified them correctly. Do y'all feel pretty good about this so far? Any questions? We added and subtracted radicals. Now we are going to multiply radicals. And then we multiplied radicals, okay? Now, guys, we are going to do our very last thing here. We are going to talk about dividing radicals, okay? So, y'all feel pretty good about multiplying? Now we're going to talk about dividing, okay? So for dividing radicals, there's a few different ways. The biggest rule with dividing radicals is that there can be no radicands in the denominator. There's no fractions in the radical, and but the big rule is there can be no radicands in the denominator. Okay? So these are our big rules with dividing radicals that we have to remember. Okay? And how we get rid, and the reason why is because what we call it is we call it rationalizing the denominator. Okay? And how you rationalize the denominator is you multiply it by a form of 1 to remove the radical from the denominator. So, we are going to rationalize the denominator, and you multiply by a form of 1 to remove the radical from the denominator. Now, guys, the reason it's called rationalizing the denominator is because, guys, anything under a square root is an irrational number, and you can't have an irrational number in your denominator. So we rationalize it by multiplying by the form of 1. Basically, itself over itself. I'll show you. We'll have a few examples here, okay? Now, we do have to do some simplification and some different things here, but we'll see. I'll help you guys get there, okay? So, the biggest thing about dividing radicals is there can be no radicands in the denominator. Now, sometimes it works out really nicely, and there are no radicands in the denominator. Okay? So I'm going to show you guys these first two examples. These are going to be really nice and pretty. Okay? So if we take the square root of 11 over the square root of 36, we are going to break up. Remember, we have that quotient rule there. We're going to break it up into the square root of 11 over the square root of 36. Do y'all feel good about that? Now, what's the square root of 11? Well, it's just the square root of 11. Do y'all feel good? We aren't really changing it, are we? So that's just still the square root of 11. But what is the square root of 36? 6. So this becomes square root of 11 over, and I'll do it in a little orangey guy here, the square root of 11 over the square root of 6. And that is our little answer there. Do y'all feel good about that? Do we have any radicals in our denominator? No, we don't have any fractions in our radicand, so we're good. Okay? So now I'm going to take a look at, I'm going to do another example here. Okay? But I'm going to do this one as the square root of 10 over the square root of 18. Now, guys, we could go ahead and separate it, but that's actually not going to help us a whole lot, okay? We want to go ahead and simplify it before we separate it. So is there any way that we can simplify 10 and 18? Is there a way we can do that? Yeah, they're both divisible by 2, right? If we divide them both by 2, then this is going to actually be the square root of 5 over the square root of 9. Is that easier to simplify? Yes, that is going to be so much easier. Why? Because of this square root of 9. So the square root of 5 stays the square root of 5. It's not going to change at all. But what's the square root of 9, y'all? 3. So that's just going to be over 3. So that's going to be the square root of 5 over 3. And that is our final answer. Do y'all feel pretty good about that? Dividing radicals like that. Okay? So you guys can simplify them a couple different ways. Now we're going to take a look at what happens. Let's see. Okay, I'm going to do number 3 here. Okay, now I'm going to start kind of using different rows. So I'm going to do the square root of 125 over 10. Alright. So we need to simplify this 125, don't we? So, what's another way we can write the square root of 125? Is there anything else that's divisible by? What is it? 25, right? So I'm going to say this is the same thing as the square root of 25 times its 5, right? You can always double check yourself. 125 divided by 25. Yes, 5. Whew. Okay. Okay, and we're still over just 10 here. Alright? So what's the square root of 25 here? That's going to be 5 square root of 5 over 10. Are we fully simplified, y'all? Are we fully simplified here? Can we reduce the coefficients here? 5 and 10? Can we divide them both by 5? So we are going to actually just have the square root of 5 over 2. How do y'all feel about that? 5 over 10 can be like 1 over 2. It's like 1/2, right? So that's going to be square root of 5 over 2. And guys, don't forget, you can always check yourself. Square root of 125 divided by 10 is the exact same thing as the square root of 5 divided by 2. Look at that. My two little irrational decimals are exactly the same. All right? Now we're going to look at number 4 here. All right? So far, we haven't had any radicals in the denominator. So far, we've just been simplifying. Now let's see what happens when we have a radical in the denominator. So we are going to have square root of 7 over square root of 8. So I'm going to separate this out into the square root of 7 over the square root of 8. Are you guys comfortable with that? Let's simplify our radicals here. So the square root of 7, can we simplify that, or is it already simplified? It's already simplified. And what about the square root of 8? Can we simplify this guy? What can we divide it by? Square root of 4 times the square root of 2. So this is going to be equal to the square root of 7 times 2 square root of 2. Are you guys good with that? But we have a problem, don't we? We have a problem. So we need to rationalize this denominator. So how are we going to rationalize our denominator here? What do you guys think? We need to multiply by a form of 1 to remove that radical. So in order to remove the radical from the denominator, what I'm going to do is I'm going to multiply by the square root of 2 over the square root of 2 to get rid of that square root of 2 in the bottom there. Alright? And when I do that, 7 times the square root of 2 is, or times square root of 7 times square root of 2 is the square root of 14. Are you guys comfortable with that? And now, guys, we are going to multiply just like we did over here. 2 times 1, so that's going to be, this is over 2. And then radical 2 times radical 2 is going to be times radical 4 there. Okay? Well, this is going to be the square root of 14. Now, guys, this is just really 2 times 2. Are you guys comfortable with that? Which is going to be over 4. So your final answer is 14, square root of 14 over 4. Do y'all feel comfortable with that? Maybe? You guys okay right there? Any questions? No? Alright, we're going to do 3 more examples here. Alright? No, just 2 more. Now here's the deal. One thing I do want to show you guys is you actually could have done this a couple different ways. So check this out. If I had written radical 7 over radical 8, and I was here, guys, I also could have multiplied right here, up here at the beginning, times radical 8 over radical 8, if I wanted to. And that would have given me the square root of 56 over the square root of 64. Well, guys, what's the square root of 64? It's just 8, right? So this would have been equal to, well, can we simplify the square root of 56? Absolutely. We can simplify that into the square root of 4 over the square root of 14. And that would have been over 8. The square root of 64 is just 8. And that would have simplified into 2 times the square root of 14 over 8. And this would have reduced down to 4. So we still would have ended up with the exact same answer, the square root of 14 over 4. It just depends on when you want to simplify your radicals. Does that make sense? You can get rid of that bottom radical at the very beginning, or you can get rid of that radical in the denominator at the end. Does that make sense, guys? You can do it either way. You're still going to be simplified in both ways there. Alright? So let's take a look at number 5 here. Alright, for number 5, I'm going to say 3 radical 2 divided by radical 14. Okay? So what we could do is we could just go ahead and multiply by radical 14 right now. Do you guys want to do that? Okay, let's do it. So if we multiply by radical 14 over radical 14, that will give us, let's see here, oh, I was supposed to do that in pink, wasn't I? Dang it. I'm not keeping my colors straight. So that would be what? That would give us 3, that's going to be 3 times the square root of, what is that, 28 over, well guys, what is 14 times 14, y'all? Or square root of 14 times square root of 14 is just 14. Are y'all comfortable with that? Now we just need to fix this little guy, right? So we have 3. We're going to fix square root of 28 into the square root of 4 times the square root of 7. And that's still over 14, which is not bad. So that becomes 3 times 2 times the square root of 7. And that is, oh, that was definitely, and that's over 14. So that's going to be 6 square root of 7 over 14. Are we all done, y'all? We still need to simplify our coefficients here. These are both divisible by 2. So that makes that 3 and 7. So this would give us 3 radical 7 over 7. How do you guys feel? Yikes. You just got to keep going through the steps here, okay? You just got to keep going through your steps. All right? Let's do one more together, and then I'll let you guys get started on your homework, okay? Got one more together. All right, so let's look at number 6 here. We're going to do the square root of 27 over the square root of 32. Why don't you guys go ahead and try to do it on your own, and then we will see what we can do. I'm going to simplify mine before taking care of the radical. I'm going to simplify each of them separately, okay? But you guys can do it any way you want it. I'm going to simplify the top, then I'm going to simplify the bottom. I got 3 radical 6 over 8. So here I went ahead and I simplified my radical on top and I simplified my radical on the bottom, and then I multiplied it by the 1 over 1 there. I did not want to multiply by radical 32 over radical 32. That would have made huge numbers. And then once we did that, I was able to simplify my lovely little radicals to get 3 radical 6 over 8. Because we had 4 times radical 4, which was 4 times 2, simplified into 8. Well, guys, thank y'all so much. That was a long set of notes there, but you guys did an awesome job. So now